At RES4AFRICA, we stand for Africa. We believe in its huge potential. We believe in its innate energy. We believe in its growth. And we believe that all it needs is an enabling environment for its full development. At RES4AFRICA, we care for Africa. That's why we believe that clean energy is the only way to go, because renewables mean more affordability. Because renewables mean more jobs. Because renewables mean more value. Because renewables mean more resilience, social justice, and health. At RES4AFRICA, we join for Africa, a unique blend of expertise along the whole value chain of renewables, joining forces to accelerate the transition towards a sustainable and inclusive future. At RES4AFRICA, we innovate for Africa. We constantly look for new, improved energy solutions to provide not just clean and powerful electricity, but also cutting-edge and reliable plants, electrical grids that guarantee quality and stability through digitalization and storage. At RES4AFRICA, we act for Africa. We promote dialogue between governments and private players to define conscious, long-term policies, encouraging adequate investments. We share know-how with all stakeholders to promote the full development of Africa together. We train locals on the field to share our expertise and make them owners of their energy. And we never, ever stop looking for new and win-win business models made of African DNA. We are RES4AFRICA. Our mission is to build a better future through better energy. In Africa, with Africa, for Africa.
Good morning, everyone. Welcome to the last session of the RES4AFRICA Labs. I'm Lorenzo Villona. I'm a program officer at the Sub-Saharan team and in Grids4Africa. And today I'll be your moderator. For this last session, we've chosen an interesting topic. It's a hot topic. Everyone's talking about it. It's green hydrogen, and we're going to be giving a focused overview on this topic and its potential as an enabler of large-scale renewables and their rollout across Africa. So the structure of the session is that we'll start providing an overview of the related technologies with a special focus on electrolyzers. Then we'll also analyze the current situation of the sector in Africa, illustrating the case of Morocco and its national hydrogen roadmap. And lastly, we'll conclude with the session with some insights into green hydrogen certifications in Europe with the European Commission's RED2 directive. That could be used as a, let's say, a best practice example for hydrogen certification. So it's quite an intensive agenda. I want to leave the floor to the experts on the topic. And so I think we can go ahead and start straight away. So I'd like to give the floor to Ms. Pierozzi, who is the Carbon Reduction Excellence Technical Manager at RINA. So I see that you are connected. I see you can hear well. So I'll leave the floor over to you, Ms. Pierozzi.
Thank you, Lorenzo. Good morning, everyone. I introduce myself. I'm Natalia Pierozzi and work as Technical Manager in RINA, dealing with all technologies related to energy transition in the streams of hydrogen and derivatives and CO2. In brief, RINA is an Italian company working worldwide with several offices also in Africa. It is a multi-service company operating in the field of certification, inspection, consulting, engineering, and testing, and is strongly committed to the cause of energy transition, working as a system integrator in decarbonization projects and providing a wide package of services in all the building blocks of the value chains of hydrogen, ammonia, biofuels, e-fuels, and CCUS. Today, I will speak about electrolyzers, the technology to produce the so-called green hydrogen without producing greenhouse gas emission, releasing greenhouse gas emission into atmosphere. Next slide, please. Hydrogen in general and green hydrogen in particular are hot topics today. Why? If we speak about decarbonization, the mantra is renewables, the mantra is electrification. However, renewable energy availability is not programmable. Plants are often not located where energy is needed, and storage and transport can be a relevant issue. Moreover, not all processes can be electrified. For example, I'm referring to the so-called hard-to-abate industry. Hydrogen is an enabler of large-scale renewables rollout because can overcome the issues of intermittence and impossibility to electrify some sectors. Today we will pass through the pathways, the colors of hydrogen, the green hydrogen value chain, how an electrolyzer works, what is the state of the art of electrolyzers, the cost of electrolyzers, and the developments, improvements we can expect from the future. Next slide, please. Hydrogen can be produced using several processes and feedstock with varying efficiencies, environmental impacts, and costs. Some colors are often attributed to hydrogen to provide information about the way it is produced, the energy sources, and the climate neutrality. The slide reports some of these pathways, some of these colors. It is not exhaustive, even if we have to say that in a near future, probably the concept of colors will be overcome in order to specifically refer to the emissions, to the processes, not just in terms of colors. Anyway, let's start with gray hydrogen. Gray hydrogen is extracted from fossil sources such as methane, coal, and results in a massive production of CO2. The process used is the steam reforming. Blue hydrogen is gray hydrogen plus CCUS. So the process is exactly the same, but I capture the CO2 that is emitted during the process. So we have lower emission into atmosphere released when we produce blue hydrogen. Green hydrogen, the topic of today, is produced by electrolysis of water using only electricity from renewable energy. In this case, emissions related to production are really low. Same for pink hydrogen that uses electrolysis as well, but the input electricity comes from a nuclear plant. We have then turquoise hydrogen. The process in this case is pyrolysis. So high temperature process, high temperature reactors that split carbon and hydrogen starting from natural gas. We have, in this case, low CO2 emissions too. Last but not least, yellow hydrogen that uses again the electrolysis process, electrolyzers. In this case, the electricity comes from the grid. Next slide, please. In this slide, I reported the greenhouse gas emissions related to the different pathways and the costs. The bars, the colored bars you can see refer to emissions. Both direct and indirect emissions are reported, where by direct emissions we mean emissions associated to the process itself of hydrogen production, while for indirect emissions we mean the emissions related to feedstock and energy supply chain. So we can see as gray hydrogen is the most polluting one. For the green and pink hydrogen, we have some emissions, as we were saying, not related to the production itself, but to, for example, feedstock and energy supply chain. I also reported some figures for the costs. So we know that costs are changing a lot. This data refer to 2021. At this stage, we can see that the cost for green hydrogen is higher than gray and blue. We will have a dedicated slide to speak about costs and what we can expect for the future. Next slide, please. We now focus on green hydrogen and electrolyzers. The machine that uses the electrolysis process to obtain hydrogen is the electrolyzer. It converts electrical energy into chemical energy, making it possible to store it, convert into further energy vectors, transport according to the most effective manner, and use it as a feedstock, as a fuel, or transform it back to electricity. This is the value chain. The production of hydrogen is a fundamental building block of the value chain, but to ensure large-scale deployment, an holistic approach has to be adopted, and so all the building blocks of the value chain have to be taken care. And their deployment, their financing, their installation has to be warranted. Design, manufacturing, and operation of electrolyzers has to be done in parallel with renewable projects that provide the required electricity to electrolyzers, but also together with infrastructure for transport. And we can't forget the demand. We can't forget the off-takers. We need industries, we need off-takers asking for hydrogen. Next slide, please. How an electrolyzer works. Water electrolyzers are electrochemical devices that split water molecules into hydrogen and oxygen by the passage of an electrical current. The core of an electrolyzer is the electrolytic cell, where electrochemical reactions take place. According to basic principles of electrochemistry, the electrolysis of water occurs when the current passed between the electrode immersed into an electrolyte, giving rise to a number of reactions at the two electrodes, and the two products of the reactions are released, hydrogen and oxygen. Once they are released, they shall be separated physically in order to have the two streams, the two output streams, oxygen and hydrogen. Next, please. So the core, we have just spoken about the core of the electrolyzer, the cell. We then have two further levels to obtain an electrolyzer. Second level is the stack. The stack is composed by several cells. In addition, there are some other components to make it mechanically stable, to avoid leakages, to guarantee that good reaction take place. But basically, at the stack level, we have several cells. And then we have the system level, where the stacks are put together with the balance of plant. So we will need electrical components, we will need water treatment, cooling, drying, and this is the electrolyzer, stacks and all the balance of plant. Next slide, please. I'd like to provide you some figures to understand the volumes of water involved, to understand the electricity consumption of an electrolyzer. We already said it. Green hydrogen production uses water and electricity to obtain oxygen and hydrogen. The stoichiometric value of water is 9 liters per kilo, if this is pure water. But then actually vendors say they need 10, 11, something more if we use deionized water as input. If we consider tap water, then we will need 20, 25 liters per kilo. So water topic is an important topic when we speak about electrolyzer, because they are water consuming. It is possible to use desalinated water, but areas where water is a scarce resource, for sure deep assessment have to be made. What about the electricity consumption? In order to obtain 1 kilo of hydrogen, we need about 40-60 kilowatt. This figure highly depends on the type of technology that is used. These values refer to the whole electrolyzer system. And in the future, we expect to improve a bit these figures. We need 40-60, let's say average value of 50 kilowatt per kilo. We obtain 1 kilo, but how much energy is inside 1 kilo of hydrogen? If we consider lower heating value, we can say that it is about 33 kilowatt per kilo. If we consider higher heating value, it will be 39. So we have about 50 kilowatt of electricity in input, and to obtain 1 kilo of hydrogen. This kilo of hydrogen will have chemical energy lower, for sure, than what we had in input. How much? About 33, 39. That corresponds to an efficiency of about 55-75%. And once we have 1 kilo of hydrogen, how much space do we need? At normal conditions, we need about 11 cubic meter. Next slide, please. We have just seen how a general electrolyzer works. Actually, there are different electrolyzers with slightly different reactions, operating conditions. Currently, there are 3 main technologies which are used, which is alkaline, proton exchange membrane, and solid oxide electrolyzers. Anion exchange membrane is the newest between them. Each of them has its own strength and weakness. Let's start with alkaline electrolyzer. It is currently the most mature technology, the cheapest one, highest stack lifetime, as a result of decades of use by the industry. PEM, proton exchange membrane electrolyzers, have seen a great development in the last decade. They have now an established position in the market thanks to its flexibility and smaller footprint with respect to alkaline. Their ability to adjust the power to suit the surrounding conditions make the PEM the ideal candidate to work with renewables. This technology is, however, more expensive than alkaline, especially for the use of precious materials as well as scarce materials. So the use of this material can be a bottleneck to the large deployment of a proton exchange membrane. Solid oxide electrolyzers work at high temperature, alkaline and PEM not. As well as anion exchange membrane. They all work at about atmospheric temperature or so. Solid oxide electrolyzer belongs to the group of electrolyzers working at high temperature, about 500–900 degrees. And the use of high temperature reduces the electricity demand, helps the reactions to take place, resulting in very high efficiency, 90% and more. It has reached commercialization, even if it is not as mature as the first two. Anion exchange membrane, the newest of the four technologies, it is still under development. It can be found in the market. However, performances have still to be fixed in terms of lifetime profiles, performances, cost reduction. Next slide, please. I reported here some figures for the specific electrolyzers 2020 and projection to 2050 for the four electrolyzers. And as we were saying, we can see that efficiency is the best one for solid oxide electrolyzers. In the bottom of the slide, you can see a typical plant. This is a 20 megawatt electrolyzer system. It is composed by 2.5 megawatt repeated in 4 modules. So we will have electrolyzers on one side with the respective rectifiers on the other side, and then we will have all the ancillaries we need. We will have the electrical room, the electrical substation, the control room, the water treatment system, cooling, thermal management system, hydrogen purification system. A unit like this, corresponding to 20 megawatt, has a footprint of about 20 by 25 meters. According to IRENA, 1 gigawatt plant could occupy an area equivalent more or less to Manhattan, just to provide some information on the footprint of this technology. Next slide, please. Among this technology, there is not a winning one. Each of them provides different characteristics and has to be chosen according to the specific project setup. They shall be selected on a project basis according to the specific requirements of the application scenario. We can say, however, that alkaline well suits large-scale industrial installations requiring a steady hydrogen output at low pressure level. So it will be typically grid connected, close to the industry, to the off-taker, and working with high utilization and steady load. For the proton exchange membrane, this is well suited for off-grid installation powered by renewable energy sources. In this case, it is more likely that PEM will be located close to renewable plant, and then conversion transport will be needed. The small footprint, the low maintenance needs make the PEM the ideal candidate to work, for example, in offshore environment. Solid oxide, they work very well when they are coupled with plants with waste heat. For example, methanation processes, ammonia plants, refineries, and so on. Next, please. This is the slide about cost. How much will it cost to produce green hydrogen? There are different factors influencing the cost of hydrogen. The most important components are the renewable electricity and the cost of the electrolyzer itself. There are also other parameters that are, for example, the size of the plant, the year of procurement and installation. I selected this graph from IRENA 2022 because it provides a trend of hydrogen cost until 2050, considering many of these parameters. So we can see that the orange lines and area refer to high electricity price. It should be 60 if I can read well, $65 per megawatt, while the green one refers to a lower electricity price, $20 per megawatt hour. And then you can see the different scale of the plant, 1 terawatt and 5 terawatt for the light orange and light green. So what we expect is a decreasing trend until 2050. The cost reduction is due to an improvement of the efficiency of the electrolyzers, an effect of upscaling of the electrolyzers that will also impact on the cost of the electrolyzer itself. So we derived that low cost of electricity, so green lines, are necessary to produce competitive green hydrogen, while cost reduction of electrolyzers is not enough. Putting together the two things, in case both electrolyzer cost reduces and electricity price becomes lower, in this case $20 per megawatt, we fall in the area of competitive green hydrogen costs with fossil fuels, or better with gray and blue hydrogen. Next slide, please. That is my last slide. What can we expect from the future? Even if the different types of electrolyzers stand at different reading level, are characterized by different conditions, for all of them we expect research and development on technologies in order to allow cost reduction, performance improvements, both on novel concepts and improvement of the existing ones. For sure, one important trend will be of the research and development will be the reduction of use of the critical raw materials. We expect an upscaling of electrolyzers up to the gigawatt scale, bringing cost reduction, but also manufacturing capacity increase, automation, bringing then automation of the production process and standardization of the system. From jobs, from skills point of view, we expect we need trained, qualified personnel. And we cannot forget the value chain. As we were saying, we cannot produce green hydrogen if we don't have green electricity, we don't have the infrastructure to transport hydrogen up to the point of use, if we don't have the off-takers asking and buying hydrogen. This was my presentation. Thank you.
Thank you very much, Ms. Pierozzi, for that very clear explanation of hydrogen, its various forms, its applications. It's a very interesting technology, and I'm sure that many people got some clarity out of your presentation. So thank you very much. I'm sure if there are any questions, we can collect them later and share them with you through email. So thank you once again. I think now it's time for us to, thank you. It's time for us to move over to our next speaker. My colleague, Mr. Paolo Cutrone, who's the area manager for the North Africa region through our RES4Med program, who will be going a bit deeper into the case of Morocco and their national hydrogen roadmap, which is quite interesting. One of the few countries in Africa, which is, and actually one of the few countries globally, really, which has started to put out a hydrogen roadmap. So, Mr. Cutrone, it's over to you.
Thank you very much, Lorenzo. I hope you can hear me and well, actually.
Yes,
perfect. So good morning, everyone. I spend a few words just introducing myself. As my colleague Lorenzo said, I'm a RES4Med area manager at RES4AFRICA Foundation, which means that I coordinate all the activities of the foundation in North Africa when it comes to studies, analysis and reports on events and webinars, and also training activities. My presentation today will delve deeper, as said, into two main topics. One is the, let's say, the African positioning with regards to green hydrogen. And the second topic is the case study of Morocco. We as a foundation, and I chose Morocco for this presentation because Morocco was maybe the first country in Africa to publish a green hydrogen strategy. And that's why it is interesting to understand how the country positioned itself with regards to this topic. So next slide, please. So let's start from green hydrogen in Africa. The first question that comes to the mind is why? Why shall we discuss about green hydrogen in the African continent? So first of all, as we have already said, green hydrogen is considered as one of the key strategic components of the energy transition. And of course, in these current years, also a component of energy security and economic development. In the African context, we have some countries, we will see that later, that are pioneering the development of the sector. Morocco is one of them. Of course, when we talk about green hydrogen production, we are not talking only about Africa, but at the same time, the continent is really attracting attention. Attention from international investors, attention from international organizations, and of course, attention from companies developing these technologies. Why? First of all, one enabling condition is the renewable energy potential. We know that Africa is really rich in terms of renewable energy resources and natural resources in general, and we know that renewables are developing a lot in every region of the continent, and actually we can see that in the future the continent will be a competitive powerhouse in terms of green energy production. The second point is that starting a green hydrogen sector could really diversify the means that we have at our disposal for the energy transition and our reduction of emissions, CO2 emissions. And this can be coupled with an industrialization strategy. So green hydrogen is an opportunity for new industries and markets in the continent. And finally, we don't have to forget that many African governments are supporting the carbon neutrality targets and strategies, are implementing and are designing carbon neutrality targets and strategies. And this is true for all the time frames, so 2030, 2040, and 2050. Next slide, please. On the other side, we need to understand that Africa has some specific features. And when we talk about the development of green hydrogen, we have opportunities and challenges. As opportunities, we have listed some here in the left-hand part of the slide. We can see that, for example, green hydrogen could be one solution to decarbonize hard-to-abate sectors, so those sectors which are hard to decarbonize with electricity, let's say, and could be a way to match the local industrial demand, which is growing. One other opportunity, as I said, is energy security and, of course, energy transition. Another opportunity is, for example, when there will be the possibility to have green hydrogen production infrastructure, some infrastructure connected to that, such as desalination, could be used for other local needs. Another opportunity is the possibility to unlock the job creation potential. It's a totally new sector with totally new job positions required, and this could be an interesting opportunity. Of course, this could be also there could be also an opportunity to industrialize through hydrogen-related technologies and improve the skills of the African workforce. On the other hand, there are some challenges, of course, which are specific to the continent. First of all, it is important to understand what are the local contexts and the existing and supporting infrastructure. Then, of course, as said by Ms. Pierozzi, it is important to understand with the localization of consumption and production pools in geographies, and of course, in terms of supply and demand for green hydrogen. There is another topic which is related to access to energy. So it is important to prioritize renewable energy investments for access to electricity, and then accompany with investments in renewable energy for green hydrogen production. It is important to, of course, foster transparency while implementing the new policies to develop this sector. And finally, it is important to, as we said before, to take care of the environmental issues and safety issues. Next slide, please. So how do we see that? How it is possible to develop this sector, taking into account these specificities? First of all, the Green H2 strategy, so the development of a strategy, of a country strategy in this sector should be seen as part of a more comprehensive strategy related with the energy transition. So we should integrate Green H2 policies let's say, in the broader design of the energy strategy and policies, having as objectives always energy access, renewable energy deployment, positive social impacts through job creation, and of course environmental integrity and natural resource efficient natural resource management. Another point is that it is important to create an ecosystem, because green hydrogen production and transportation and storage is a complex endeavor, so involving multiple companies and stakeholders, it's very important, and trying to understand how the logistical value chains work is, of course, an asset. The third point is to have as a beacon, let's say, the knowledge and technical and human capacities, so that we use this opportunity to build a new workforce and to boost the economic growth in the continent. As I said, the multi-stakeholder partnership should be not only on the company side and investor side, but should include also institutions, universities, research centers, and so on. And finally, the priority should be, one of the priorities should be the environmental impacts and safety and the guarantee of safety for the people working in the sector. Next slide, please. So I put here some numbers just to connect to Ms. Pierozzi's slide on the costs. As you can see here, you have the supply cost curves for some African countries in 2050. You have two scenarios here, an optimistic scenario and a pessimistic scenario. These data are taken from the IRENA report of 2022. We have already mentioned it. As you can see, there are some countries which are really on in the line to, let's say, on a path to have cost competitive production of green hydrogen. For example, here you can see Egypt, which is in a quite good position, both in the optimistic scenario and the pessimistic scenario, to produce green hydrogen at a cost which is around $1, let's say, in the optimistic scenario, and around $2 in the pessimistic scenario. Next slide, please. There are, as I already mentioned, there are some initiatives. There are some cross-country initiatives in Africa, and some initiatives connected with the European Union. For example, there is in the European Union hydrogen strategy and hydrogen Europe. Sorry, there are some. I mean, the partnership with the African continent is fostered and promoted. There is the African Hydrogen Partnership, which is a sort of an umbrella association for all the technology producers and companies in the sector. And then we have some national initiatives. Morocco, I will delve deeper into later. But as I told you, Egypt is quite on the line to become a hub for green hydrogen production. In 2023, they published a national strategy on green hydrogen in cooperation with the EBRD. We have Namibia with some projects in the pipeline. We have Mauritania with some very large-scale projects in cooperation with some private companies, and of course we have South Africa, where the government is moving towards hydrogen, both on the production side, but also on the side of technology production. So the African continent is moving towards the development of a green hydrogen sector. Next slide, please. Yeah, so now we talk about Morocco. And next slide. Okay, so here you have some numbers from the Morocco National Hydrogen Roadmap. The roadmap was published in 2021, and it has been developed by several stakeholders at the national level. And here you can see that it's a very ambitious strategy. You can see that also here the country has decided to identify some, let's say, optimistic scenarios and reference scenarios for 2030 and 2050. As you can see from the potential identified in the National Hydrogen Roadmap, export is maybe the most important component, both in the medium term and the long term, but there is also industry and transport. We are talking about a demand which is identified as 9 million tons in 2050 in the optimistic scenario. as Ms. Pierozzi said, it is important to understand how the production part works in order to understand how to develop the sector. And actually in the hydrogen roadmap, we have some information about the expected renewable energy capacity to reach that numbers in terms of production. We're talking about 80 gigawatts in 2050 in the reference scenario, so a huge renewable energy capacity. As for the electrolyzers capacity, we are around 30 gigawatt and 50 gigawatts in the two scenarios. And we have also some information about desalination plants. Actually, since Morocco is a water scarce country, the government tried to identify what were the needs in terms of desalination. And I want to highlight here that actually this desalination capacity, which is an energy consuming technology, will be powered by renewable energy in the idea of the energy strategy. We're talking about 50 million cubic meters a year, or 70 in the optimistic scenario. I just want to go to the, let's say, the costs, which are important. In order to reach these numbers, we are talking about a very, very large amount of investments. We're talking about 40 billion dirham in 2050, which is around $40 billion, and 500 billion dirhams in 2050 in the optimistic scenario. Next slide. Yeah. Here, I hope you can see I put the timeline, which is quite important to understand how the country is positioning itself in terms of technologies and end users, which are really important, and off-takers, I mean, which are really important to understand how the feasibility, let's say, of a strategy. If you can just click, maybe we can see the rectangle, Alberto. Thank you. So you can see that one of the first development expected from Morocco is towards exports in 2030, 2032, more or less. But we have also some important development in the industry sector. And why? Because Morocco has one of the most important fertilizer industries around the world. And actually green hydrogen could be used to produce green ammonia for the fertilizing industry in order to substitute imports of ammonia, which are now quite impressive, quite important in Morocco. Then we have some options for the development of green hydrogen in the long range transport sector. And of course, we have also some ideas to use green hydrogen for the flexibility of the electricity system at the country level. Next slide, please. Just to understand, I was saying that one of the most important things in order to build a proper strategy is to put together all the most important stakeholders and actors which could be implicated in the green hydrogen sector. And this is what the country as the kingdom has tried to do in the hydrogen strategy. So here you have a list of the most important actors. You have both national and international actors. And these actors are categorized on the basis of the, let's say, their role. So you have public policies support, you have the ministries, you have utility, ONE, you have the OCP group, which is the producer of fertilizers, as I said, you have MASEM and other important public actors. On the other side, you have international actors such as international donors and financial institutions. You have research and development actors, which are important as well. Both on the national side, Morocco has developed really an ecosystem of research centers and universities dedicated to this sector, with also some support from international leading research centers. And then you have the most important companies and the capacity building and training actors. The efforts of the country are coordinated, but by let's say 3 main actors. One is the National Hydrogen Commission, which is a commission at the, let's say, government level, with the aim of directing and monitoring the completion of studies in the first part of the strategy, and then, of course, the implementation of technologies and production. Then you have Green H2 Morocco, which is a cluster, actually a sort of group dedicated to the emergence of a competitive Green H2 sector in the country. And of course, not just competitive, but also collaborative, because as we said, we need multiple actors in order to build this value chain of production, transportation and storage of green hydrogen. And finally, you have the Moroccan Association for the Hydrogen Sustainable Development, the AMHID, which is an association which brings together all the laboratories and companies that are working on this. Next slide, please. So a couple of challenges that we have identified with the Moroccan stakeholders in a study that we have published as a foundation in 2022. There are, I mean, as we said in the first presentation, it's a complex system, and it's a complex system from a technology point of view, and also from a regulatory and policy framework point of view. Then there are also some other important aspects that I will touch upon later. But in any case, there are some challenges. For example, can you, Alberto, can you just click so that we identify the most important? Thank you. For example, on the production side, here you have a lot. I won't go deeper into all of them, but on the production side, renewable energy generation costs are still higher in Morocco than in other places around the world. So since this sector will be very competitive at the global level, and Morocco has identified exports as one of the most important demand drivers in their strategy, it is important to reduce the cost of renewable energy. And of course, in the country, there is still room for improvement. The second point, Alberto, can I ask you to click, is water scarcity. As we said, Morocco is a water scarce country. Desalination has been taken into account in the hydrogen strategy, but at the same time, this makes everything a bit more complex, and of course more costly, because the cost of desalination has an impact on the LCOH, the cost, let's say, of production of hydrogen. Now, a third point, please, Alberto. Yeah, is of course we have seen that Morocco is a very large country, and we have seen this posture towards exports, and so transport and costs of transport are really important when we talk about the development of the sector. So it is important, and this is not completely clear from the green hydrogen strategy. It is important to understand if these exports are going to be carried out through pipelines, which are not there at the moment, or through shipping. And this has an impact on the costs and on the competitiveness of the country as such. And finally, I've Alberto, if you can click, I have a final point, which in some way recaps all these points in the end users. So if the strategy is focused on, for a large part, on exports, the hydrogen, Morocco could be exposed to the conditions of the international green hydrogen market. And this, of course, could make things a bit more difficult. But at the same time, the country is on the line for developing this sector, because there is an important off-taker, which is OCP. We have talked about off-takers with Ms. Pierotti, and so this this is a very positive point and an enabling condition to develop, let's say, the first steps of the green hydrogen market. Next slide, please. So in this study, we have also proposed some measures to completely unlock the green hydrogen potential. And I want to stress again, these measures were proposed after a series of interviews with Moroccan stakeholders and international stakeholders. We have also based these measures on a review of the best practices at the global level in terms of the development of green hydrogen sectors. We have analyzed more or less 13 or 15 countries in their efforts to develop the sector. So we have divided those measures in three parts, in three groups, let's say. One is strategic positioning. And in the strategic positioning, we have some indications. I just want to focus on the first one and the second one. The first one is to try to understand what could be, we have talked about potential. So it is important to understand what could be really the quantified target. So what part of that potential could be reached within a certain amount of time. And that's why it is important also to have intermediate targets in the short to medium term to facilitate monitoring and evaluation and, of course, development of the sector. This is true for the countries that we have analyzed around the world. The second point is to try to understand what is the role of green hydrogen compared to other energy sources in order to avoid overlapping in some sectors. Let me go to the next slide and I will conclude. So we have other two categories. One is implementation and support, and the other one is governance. As for implementation and support, of course, it's very, very important after having a strategy as the one that has been published to design and implement an integrated and coherent policy and regulatory framework. And of course, this is important because it gives some visibility also to international investors. A second point, which is fundamental, is to understand what financial mechanism could support the development of green hydrogen while we reach, let's say, the competitive prices, competitive price with gray hydrogen. And a third point, which I won't dive deeper into because it will be analyzed by Ms. Severino in the third presentation, is certification and guarantees of origin. And the third category is about governance. We have seen that Morocco has a clear governance in this strategy, and the kingdom is trying to involve all the possible stakeholders. So the country is really advancing on this, but it is really important to avoid overlapping between actors and try to reduce the complexity in order to speed up the process of development of the green hydrogen sector. I think I've finished here. Thank you very much.
Thank you very much, Paolo, also to you for another very clear presentation. It's very interesting to see. I don't know what the geographic background of our participants are today, but I think there's a lot that can be learned from the Moroccan case, and that could potentially also be applied to a lot of the countries of our attendees today. So it's a leading example, together also maybe with Namibia. But so yeah, thank you again, and thank you also for your perfect timing so far. It's been impeccable. So I will not keep us any longer, and I'll continue with our timings, which is everything's going on schedule. And so I'll hand immediately over to Ms. Laura Severino, who's Head of Climate Neutrality and Chain of Custody Sustainability Strategic Center at RENA, who will be talking about the certifications for the hydrogen market. So without any further ado, Ms. Severino, please go ahead.
Good morning. My name is Laura Severino. I am the head of the unit in RENA Services, responsible for certification services related to sustainability, including those for carbon management, but also sustainable fuels. The title of my presentation is Certification to Foster Hydrogen Markets, so the last step, certification. Next slide, please. Okay, first I start describing what is the context. A new global hydrogen market is forming with public and private actors across the supply chain coming together. Today, a cohesive, uniform and shared certification system is missing. There are many certification schemes, but a unique certification system is missing. Why is certification so important, relevant? Because assurance on the sustainability of hydrogen supports a collaborative framework between importing and exporting countries, facilitating market participation for all the stakeholders. And finally, I conclude my presentation with some key questions. How is a certification scheme made, and what is the status of hydrogen certification scheme? Next slide, please. Okay. This slide describes the network of hydrogen trade routes. The new global hydrogen market bring with it geoeconomic and geopolitical shifts compared to the oil and gas trade. A broader market composed by many energy exporters serving a small number of importing regions. Potential exporters are all the countries characterized by land availability and good quality renewables, and the traditional oil and gas exporting country will be flanked by newcomers like Chile, Morocco, and Namibia, etc. And the technology transfer, like anticipated by the previous speech, infrastructure investment at scale are necessary to make this possible. Next slide, please. Okay, Africa combine good quality resources, large areas of land, and growing energy sector. And the green hydrogen represents an opportunity to satisfy the growing energy needs of the continent, while at the same time providing prospects for economic growth and industrial development through export of hydrogen and its derivatives. Next slide. Okay, certification is an essential element of any trade, especially for the development of new trade in hydrogen. Certification is a third-party activity that gives a written assurance that the subject, any type of subject, is compliant with the standards and the regulatory requirements, and is a tool to distinguish sustainable from non-sustainable goods. This is in general. And the many advantages are obtained thanks to certification. A common clear ground where the characteristics of the good to be produced and sold are clarified is needed for importer and exporter. Technical standards offer guidance and the criteria to design sustainable product. For example, for hydrogen, I anticipate that the sustainable characteristics are renewable electric energy and low carbon along the supply chain of the production of hydrogen, and ensure the quality of the product. And in many cases, certification is mandatory, or if not mandatory, is an essential element to compete in the market. Without the certification, you cannot solve hydrogen and its derivatives in the market. And enabler is an enabler and accelerator of market launch and decarbonization. Next slide, please. Okay. A successful certification scheme must capture some very important technical components defined in the standard, but also in the certification scheme, the procedure, and must have a systemic structure in order to be scalable and ensure the integrity and success of the certification. First of all, the standard must be defined. The requirement according to a product must be compliant. Standard defined, for example, in case of RED2 certification, the standard the requirements are contained in the RED2 Renewable Energy Directive. In the standard, many cases, there is also the requirement of greenhouse gas footprint. And in the standard, it's important to define how long is the supply chain, the life cycle of the supply chain for the greenhouse gas footprint. For example, from cradle to grave, from cradle to gate, and so this specific requirement. Other important elements in the standard, the data input. Which data inputs are important, are mandatory? The quality of measurement, the conversion factor, how to calculate the conversion factor in a process. And some standard also includes some ESG requirement in order to ensure an holistic approach to sustainability, not only to certify one environmental objective, but all environmental objectives, but also social objectives. So it depends. So this is some difference in the certification. Another important element for the certification scheme is the governance. Who is the owner of the scheme? Which are the role, responsibility? The owner is private. We have to pay a fee in order to obtain certification, and the governance, the rules and responsibility. The criteria to define non-conformity. Which are non-conformity? Classification of non-conformity, serious non-conformity, minor non-conformity, non-conformity that don't allow to issue the certificate, or minor non-conformity that cannot be solved in 2 months or 12 months, and so on. So the next topic is the verification, enforcement, this implementation of requirement and verification. How to maintain the certificate. The certificate can be subject to an annual surveillance every 6 months, every 3 months. The deadline of the certificate, the on-site visit is mandatory, or some activity can be carried out remotely, and so the rules for the procedure for the certification and for the maintenance of the certificate. The last important element is the chain of custody option, because for hydrogen and its derivatives, there is a long supply, can be a long supply chain, and one requirement is traceability of specific batch of product sold. And so the criteria to ensure traceability based on segregation, sustainable product segregated by non-sustainable product, or mass balance, or book and claim. Different options. There is the need of registry, digital support, and labeling. Next slide, please. So when we have to design a standard for certification of hydrogen, first of all, we have to define the certification scope. The certification scope, for example, the certification is applicable only to hydrogen, also to ammonia or methanol, to derivatives. Only hydrogen for transport, or also other use than transport. For example, now in the RED2 directive, the certification is needed only for hydrogen for transport, green hydrogen for transport. But this means that also for the European targets, also only hydrogen for transport count. So this is important. Hydrogen can hydrogen be produced in all parts of the world, or only in some regions? So, system boundary. System boundary is very important, above all for greenhouse gas calculation, and also to verify which element of the supply chain must be considered. For example, greenhouse gas emission from the construction, operation, and maintenance of the electrolyzer have to be taken into account or not? Which data must be considered? Emission accounting guidance is important. It's important in a certification scheme, define a clear methodology to calculate the greenhouse gas footprint. Emission threshold is a target. Below this target, the product is not sustainable. So it's important to define a clear target in order to distinguish sustainable product from sustainable. In European directive, for example, the target for hydrogen for transport is 70% of greenhouse gas saving. Another important element is the labeling on product, but also sustainability declaration, because every element, every actor of the supply chain must issue a sustainability declaration or a label about the specific batch of product sold to the client. And the last is ESG requirement. Like anticipated before, it's normal to add in a certification scheme also ESG requirement in order to have an holistic approach to sustainability. Next slide. Okay, the status, the current status. Certification schemes for hydrogen are evolving rapidly. Some schemes are wholly born out of industry, while some are based on government initiatives. Most mechanisms are designed for a specific country or region. In any case, there are a gap in standard certification scheme, resulting in insufficient information in certificate to allow for fair comparison across borders. On the right, some example of certification schemes. Next slide. Okay, now I focus on certification according to Renewable Energy Directive RED 2, named RED 2. The European Union has defined the mandatory target for countries in Europe to be reached by 2030. 32% share of renewable energy linked to 40% of greenhouse gas reduction, and a specific target in the transport sector, 14 for transport sector. And there is also a new proposal to set the target, to define a more ambitious target in renewable energy. Liquid and gaseous fuel from renewable non-biological sources, hydrogen and its derivatives, is one of the fuel, innovative fuel is one of the option to meet the target for country. But the large-scale production of this fuel generate concern about the real sustainability. Real sustainability, for example, greenhouse gas emissions, greenhouse gas reduction compared to fossil fuel, and the renewable origin of electricity used to produce hydrogen. And so certification is already a requirement of RED 2 directive. And so criteria to be met for hydrogen produced with electrolyzer to be considered fuel renewable are defined in the RED 2 directive, but also in 2 delegated acts that were submitted to the European Parliament and the Council for approval in February 2033. We are in the deadline, the 2 months to accept, and so the Commission proposal can be accepted or not, with the possibility to extend to further 2 months. But anyway, we are in this period. The delegated act, I think, will be accepted in this period. The first delegated act is for renewable origin. And so in order to ensure that the renewable electricity is used and additional. And there are also requirements about geographic correlation and temporal correlation. And the second delegated act is for methodology set to calculate the greenhouse gas emission saving. The certification is a requirement of RED 2 directive, is similar to certification set for biofuels. Is similar, the concept, the criteria, the supply chain is similar. The certification for biofuel is mandatory, is a requirement for the market since 2011. Next slide, please. Okay, so today there is no a EU recognized scheme approved by EU for renewable hydrogen. So since the delegated act are not official, the voluntary schemes submitted to European Union the scheme and not obtained the approval, there is not an official recognized scheme in Europe to certify hydrogen. Even if the criteria are already defined: greenhouse gas saving, greenhouse gas emissions, and renewable origin of electricity. And so, to prepare for the future, the producer of RFNBO can apply for voluntary certification. An example of certification that can be applied is, for example, ICC Plus certification. That is similar to ICCU, that is will be an approved scheme for official for certification of hydrogen. Next slide. Okay, this is some example on only to present the supply chain of green hydrogen. This slide presents the case of application certification along the green hydrogen value chain. In which case certification is mandatory for electrolyzer, for the producer of hydrogen. Next slide. Okay, in this case, another application, the certification is mandatory not only for electrolyzer but also for the production of ammonia. If at the downstream of the production of ammonia there is a trader, also the certification is mandatory also for a trader. All actors of the supply chain must be certified. Okay, next slide. Okay, to conclude, certification is an essential part of developing a global market for hydrogen because thanks to certification, organization of the supply chain of hydrogen can provide assurance of the sustainability of hydrogen in terms of greenhouse gas emissions and the renewable origin of electricity used. Thanks to certification, organization can demonstrate they adopt a responsible approach to the environment in this period in which the certification is voluntary, get incentive from government, because in many cases there are incentives for the production of hydrogen and there is the need of certification. And also organization can obtain an interest of consumer, clients and investors and obtain approval for public authorities. Unfortunately, a cohesive and harmonized system is not available now, and the current regulation presents some gaps. But anyway, the requirement defined in the European Commission RED directive can be used for certification because the requirements are already defined and organization can apply this requirement in a voluntary way and apply, for example, a voluntary certification, like, for example, ICC Plus certification. Okay, I conclude my presentation. Thank you.
Thank you very much, Ms. Severino. Another great presentation to wrap up this session on hydrogen, which I think has been very informative. It's such a new topic. Many of us, including myself, are still learning about its potential in Africa and its potential for increasing the penetration of renewables and the energy transition more generally. So this concludes the whole series of the RES4Africa Labs. So a big thank you to all the speakers today, Ms. Severino, my colleague Paolo Chitrone and Ms. Pierozzi for your participation today. Thank you to all of you who have joined us for this series. It's important to have you here, active participants in the discussion, eager to learn. Eager to join us in our mission to increase renewables in the continent. So really, thank you. You'll make the difference, and I hope you've all enjoyed and learned from today's presentation and the previous ones. In the following days, you will receive a survey to express your opinion on the labs. provide your feedback on what you liked, what we think you should improve on the format of this training. I ask you that you do fill it out. It's extremely useful for us in including our future ones, but also all other activities that we carry out. So if we can, please take time to fill out that presentation. That leaves me just one more thing to say, and that is to give a big thank you to my colleagues who have worked for this project over the past few weeks. So big thank you to my colleague Ivana, Martina, Asia, and all the team with Fabio and Alberto working on the technical side as well. So big thank you to everyone. Enjoy the rest of your week, enjoy the rest of your day. It was a pleasure having you with us.